Now I am alive. So you, yeah, just find my refresh it. Okay, folks. So now we're gonna be talking about the last topic before the test, number 3, which is a topic on special products. Uh, Special products are forms that you need to remember. No sound? Huh? You have a sound? Yeah, okay. So the special topics are, let me go back to that. I was just talking to my wife. She said that there was no sound because I need to check the stream sound. Okay, so special products. Special products are forms that you need to remember, which is going to spare you from having to go through the trial and error methods or AC method, which is a significant amount of work. But if you can remember the forms that are already ready to be factored, then it's much easier. So let me show you a couple of forms that you need to remember. First form is called the square of a sum. Square of a sum. Now this is the form. You have a sum, a plus b, two terms, right? One term is called a, another term is labeled b, and you make a square out of that. If you do that, you will get a squared and a b squared. This is what usually people think, you get a squared plus b squared, but no, sorry, you get a little more, which is the middle term, 2ab. Okay, now you can convince yourself into the correct version of this. This is identical, this part and this part. If you do the a plus b times a plus b, then you will see, oh, I can do it myself, a plus b times a plus b, and now you multiply that and you get a FOIL, you get an a squared, you get a ba and ab, which is the same thing, so you got twice ab, and finally you got the L, which is b squared, right? Okay, so that's the form. And so again, make sure you understand this. So a plus b squared is not a squared plus b squared. That would be a mistake. That this and this is not the only thing. This one also comes in the game. And the second form that you need to remember in this story is a square of difference. Now that's the same thing with a negative on the second place, and that also gives you negative on the second place here. So you need to remember that. Okay. Now how is this a factorization? Well, what you have on the right is a trinomial. Three things. What you have on the left is a product. It's a square. A square is a product. So 3 square is 3 times 3. So this is a plus b times a plus b, and this one is a minus b times a minus b. Okay, so this is the kind of the thing that you would need to remember. Okay, so again, where would that come in handy? Well, for example, if you have something like this. Okay, and now you are asked to factor this. You should recognize the form immediately. So this trinomial, 1, 2, 3, is the same as this one here, 1, 2, 3. You just need to see what is a and what is b. Now you have the square of x, so that's an x squared. That's your a. X is a. Then you have the 3 squared as 9. So you have the x and 3. So that's an a and b. And then in the middle you need to have 2 times ab. So which is 2 times x times 3. So you can see 2 times a times b, which is 6x. That's exactly what you have in the middle. So once you recognize you actually have the right side of the form here, then you can use the formula. Formula, right? You can use the formula. So the formula is x plus 3a plus b squared. So you factor that immediately. You don't need any trial and error, you don't need guessing, you don't need any AC method, nothing. You just factor that immediately. But you need to see that. You need to see this thing being exactly what you have here. So you need to see a square of something, you need to see a square of something, and that something and something, when you multiply and double, has to be in the middle. So it has to be 2 times a times b. And once you see that the story is over, you have immediate factorization. So this is x plus 3 times x plus 3. X plus 3 is a prime, so you have a prime times prime. Prime time itself, right? Okay? This is something that is very important to see, because if you see that, you're not going to have to work too hard. Okay? Let me give you another one. This is something that I don't really have in the paper, so I'm making it up. It's not in the lecture. In the lecture, you have to see that yourself. You're gonna read the lecture on special products, and that, of course, is a homework on special products. You have to do that too. But okay, so you have this form again. 1, 2, 3, 1, 2, 3. Well, you have a minus on the second place, so you gotta remember that the minus must be on the second place if there is any minus. You cannot have it on the third place. The third place is going to be positive. The first place is positive. The only place that you can have something negative would be second. You gotta remember that. This is a very, very important thing to remember. Second place could have a minus, but no any other place. Okay? So if there is a form here, this one would be in the game. Okay, let's see what do we have. So the beginning must be a square. The a squared. It is. The 2x times 2x is a 4x squared. The end must be a square, and it is. It's a square of 3. Again, I have a square of 3. It wasn't very original, right? Okay, in the middle, you need to have a 2x times 3, and you need to double that. And of course, you have a minus. I forgot minus. Okay, is it so? Well, let's see. 2 times 2 times 3, that's 12. Minus and x is there as well. So yeah, that's exactly what we have. So you do have a form, this form here. So now the factorization. This is a form that we call a square of difference form. And we keep on calling it form. You can call it formula if you like. But you have to remember this formula, this form. So you have the 2x minus 3ab squared. There you have the factorization. Now, if you attempt to do something else here, you would have a trial and error. You would have to think about it. What do you have here? 1 times 4, 2 times 2. What do you have here? 1 times 9, 9 times 1, 2 times 2. So basically, you'll be dealing with the 6 options. Oh, something's going to be negative. So you'll be dealing with the 6 options for the trial and error. Okay? You can still factor it, but it will be just a waste of time. Okay, I'm going to show you this AC method, for example. So this is a waste of time. Look how much simpler this is. 2 lines. I have this trinomial, I recognize the form, and I just factor immediately. Now, if I use a AC method, I'm not going to even try trial and error because there's lots of writing here. AC method will be, key number is 4 times 9. So the key number is 36. Okay, so now I have to split the middle one into 2 terms whose coefficients when they multiply should give me 36. Okay, it's not too bad. I can do that. I have negative 6x plus 9, because I have now negative 6 times negative 6 is equal to 36. Next line, I need to now do the factoring by grouping. So this 2x, I have to factor that, and I have an x here, 2x, excuse me. And this one I have negative 3. And this form here, I need to extract negative 3, I think. That's a work. So I have left out of this negative 3 out, 2x, and negative 3 out, so negative 3 times negative 3 is 9, so I get negative 3 left. And now the next line, I have a common factor, 2x minus 3, 2x minus 3, 2x minus 3. And what is left? I have 2x here, this part, and this one is negative 3. You can just see how much more work I have. And I come up with the same thing here. 2x minus 3, 2x minus 3. A product of two primes that is the same thing. So you can just write 2x minus 3 squared. Right? I think you can see a lot more work here. There's no need for, you don't have a need for this work if you can recognize the form from the get-go, which is much easier than this. So the form is something you need to remember. I was doing the AC method with trial and error is even worse, because you're going to have to write 6 options and you're going to check the middle term in each one of them. And there's a lot of writing here. This could also work in a situation when you don't have whole numbers, not just integer, you might have a fraction. So let's have one with fraction. So I have 1/4 x squared, and then I have 4x plus 16. So lots of people are going to say, okay, I'm not going to factor this because I have fractions. I don't factor fractions. But we do. Okay? You just need to recognize the form. This is a square. 1/4 is a square of half, and x squared is a square of x. So you have a square here. If you square this, you square 2 factors here. You square 1/2. 1/2 times 1/2 is 1/4, and you square x, you get an x squared. And this is of course a square of 4. So the next question you have, what is in the middle? Do we have in the middle what we need to have, which is this time 2. 2, and it's going to be plus, time this piece, time this piece. Is that in the middle? Okay? Is that in the middle? Just my wife says to me, I have the light that is flashing on the screen. Sorry about that. Okay, so I have the A, B, and now this is supposed to be 2AB, which is right here, if everything's right. 2 times 1/2 is 1, so that works fine. When you multiply with 4 and x, you get exactly what you have here, which is 4x. So this is perfect. So I do have exactly this piece here. I have the a squared, I have the b squared, a squared, b squared, and in the middle I have a 2 times a times b. So this is my a, this is my b, and this is 2 times a times b. So I have exactly this piece here. So what is it equal to? It's equal to a plus b squared. That's what the form says. Right here, it's equal to this. So that's a product. 1/2 of an x plus 4 times the same thing. 1/2 of an x plus 4 squared, right? That's a product. So you have a product. Done. Peanuts. Easy stuff. Okay? Let's do one factorization as a complete factorization. This is complete factorization is when you have to factor something into more than one step, because it's going to be the first factorization you're going to get is not going to be complete, so that you have to continue until you get primes. Okay, So I have something like that. 36x squared minus 24ax, and then I have 4a squared. Okay. So one thing you think about this when you see something like that, you will think about it more. Okay, maybe I do have a form here, and I do have a square, I do have a square, I do have a square, and I do have a square. So it looks like I have a square at the beginning, square at the end. Okay, there's nothing wrong with that, but if you do immediate factorization by using a form, you will not get primes. So you're going to have to continue further down the road. So the good idea is to notice, which is always the first thing you need to look for, is a common factor, the greatest common factor. Do you have that? If you have that, that's the first thing to go. So I do have that, because this is even, even, even. So at least I have a 2. At least 2. Okay? I actually have a 4, because this one is divisible with 4, this one is divisible by 4, and this one is divisible by 4. So that's going to be the first thing you're going to do. 4. And then you're going to get 9x squared, and you're going to get 6ax, and you're going to get a squared. Now it's easier. Okay? You have a square here, you have a square here. So that is square root of 3x. I know it's not attractive to have parentheses in parentheses, but you have to really think like that. And you have an a squared, and in the middle you need to have, I have a negative, so it's going to be this guy. In the middle I have a negative, it has to be 2 times this times this. Okay, so when you multiply these 3 things, you get 6ax, which is exactly what you have here. So now it's easy. So you have you have a 4, which is 2 times 2. You can write it as 2 times 2. I'm just going to keep 4. And then you have a, right? In this particular case, is 3x and a. That's a b actually, right? In the form, in uppercase b. So you have 3x minus a squared. There you go. Now you're done. So you have a 2 times 2 times this again. It's a square, right? This one is also square root 2. So you have 4 primes here. Okay? So again, I was using the extracting a common factor. You should do that. If you don't do that, you'll have to do it later anyway. Let me show you that. So you can say, who cares about common factor? Here I can see the form. The form is 6x squared, 6 times 6, x times x, right here. And 2a squared, 2 times 2, a times a, right here. So this is a, this is b, and I have this times 2 in the middle. Do I have that? Of course I do. 2 times 6 times 2 is 24. And that's what you have here. You also have an x, you also have an a, which is right here. And you have a minus. So, perfect. Beautiful. So now you have 6x minus 2a squared. This one minus this one squared. Because I'm just simply using this form, right? This here. This here. This here. There you go. But you're not done here because this is not a prime. Look. It's not a prime. Why? Because this one has 2 as a common factor. So it's 2, 2. So you got 2, 3x minus a. And the same thing here. 2, 3x minus a. So now you're done. You have 2 times 2, 4, 3x minus 2 minus a squared. So you can extract the common factor in the beginning, or you can extract it at the end, but you have to do it anyway. So, okay. All right. So I suggest there are more examples in the lecture. In the lecture there are more examples. So if you want to really have a good grade, you need to go over all of those examples. I'm not doing them all. I'm leaving that to you to read. Okay. But that's about square of a sum and square of a difference. Those are two forms that you need to remember. It will spare you from extra work if you can remember them. We have another form that is called difference of squares. And it works like that. You have a square of something minus square of another thing. Difference of two squares. And it works like this. That's all there is to it. Immediate factorization. Okay? Now, you can show this factorization by using the grouping if you go from left to right. If I go from right to left, it's just multiply. If I multiply, I get a squared, then I have an ab, then I have a ba negative, cancel, cancel, and then I have a b squared negative. So you can see I have an a squared minus b squared. I didn't have enough space, so I just write it vertically. But in one way or the other, this formula holds its identity. It's always true. So how do you use that? Well, you can also think maybe we have a sum of squares formula. No, we don't. Actually, that one does not have a factorization. Only difference of squares. Okay, this is how. This one is easy to recognize. I mean, you have, two squares. Square of x, square of 11. And there is a difference of those two squares. So all you have to do is to recognize square of what you have. So you need to find out what is a, what is b. The a is x, square of x. The b is 11, square of 11. Done. Alright? Now, what I usually get from students like you is that they get a mistake like this. They think, oh, that's x minus 11, x minus 11. No, it isn't. Because this will be a square of difference. Square of difference is not the same as difference of squares. Big difference. Square of difference and difference of squares is not the same thing. Those are two different forms. So this is difference of square form. The square of difference form is the previous story. Okay, you gotta make sure you understand this. So this is gonna go this way. Okay, that's one example. I'll give you another one. You can also do this with fractions. So I have one with fractions. X squared over 9 minus 16. Okay, so you have the square. You have the square. You might have a little problem. Some people don't see the square. I can see the square clearly. It's a square, it's a square. Square of x, square of 3. So this thing here is an x over 3 squared minus 4 squared. Okay? So now you have this form here, right there. You don't have to do anything extra. You're just going to write x over 3 minus 4 times x over 3 plus 4. I know somebody's going to ask, well, does it matter you write minus first and then plus second, or you write plus first and minus second? It makes no difference. Your choice. Okay, I wrote minus first so I don't forget it. Okay? So this is how it works. Very simple. Sometimes you might have a little more to work with. Okay? Now if you have a little more to work with, you still have to see it. Because the alternative is more work. So I have 1/9 of an x squared. Let's put x to the power of 4, so it's a different example that is in the text. Minus 4a squared b with the power of 4. Okay? So you say, well, no common factor. I don't see anything in common. This one has 2's and a's and b's. This one doesn't have 2's, nor the a's, nor the b's. So maybe I can do nothing here. Well, actually, you have to see that you have lots of squared here. Square of 3 squared. Any even power is a square. So this is a square of x squared. Square of a square is the fourth power. Square of 2, square of a, square of b squared. B squared squared is b with the power of 4. So this is what you have. 1/3 of 1x with the power of 2 squared. Square this, you get 1. Square this, you get 9. Square this, you get 2 times 2, which is 4. This one here, you also have a square. Square of 2 is 4. Square of a is an a square. Square of b is the square of b squared, excuse me, is the fourth power. Now you're done. Practically. You still have to write it down. This minus this. This plus this. You should basically copy, only put a plus in place of minus. Then you're done. There you go. Factorization. So this is multiplied with this and that's equal to this. Who would guess that? You. Because you have the form here. Right? So you got to remember this form, this formula. This formula is something you need to remember because this formula is what we call identity. It's always true. Okay? You have 2 more. Okay? Now we're going to be talking about cubes. One of them is called the sum of cubes. And the other one is difference of cubes. Okay? Now the sum of cubes is easy. You have a cube plus the cube. And difference of cubes, the same story. Now, okay. So I had a difference of squares formula just moments ago, right? So I have a difference of cubes formula. As a matter of fact, we have a difference of fourth powers formula. We're not going there. Any power you like. So the question is, how do I get a product out of this? What is the product here? What kind of product I have? Okay, this is how it goes. You're going to remember that. Both are very similar, but they're slightly different. So, similar, but not the same, right? They both have 2 factors. One of them has 2 terms, and one of them has 3 terms. I hope you can remember this. It's not really difficult to remember. I have a really good routine how to remember that. In the first parenthesis, you will write something that you have here without cubes. A plus b, a minus b. Okay? So it's the same thing you have here, only without cubes. In the second parenthesis, you will write all of the products of 2. What can you have? A times A times B, B times B. There's nothing else. So you have A squared, A times A times B, and B times B, B squared. Oh, I didn't put any signs yet. That's the next thing. All odd ones are positive. Just like before. Odd ones are positive. Odd first, odd third. Odd first, odd third. But the second one could be negative. And it must be opposite to what you have in the first parenthesis. Plus, minus here. Minus, plus here. I hope you can remember this. This is easy to remember. I find this out to be very easy stuff to remember. And for the most of the people it is. Now you can ask, oh, how is this so? Well, you can show that. It's really not that hard. Just multiply this stuff here. Let me do that. You can do the first one too. Multiply this one. So you have a times this, a times this, a times this. So you have an a times a squared, which is a cube. You have a times ab, which is plus a squared b. And you have a times b squared, which is plus ab squared. Okay? Now you have the second bunch. This one, and this one. That's how we multiply, right? B times a squared is an a squared b, but you notice you have a minus here, so this is minus. Look at that. Cancel, cancel. Then you have negative b times ab, so it's again negative abb, which is ab squared. Cancel, cancel. And you have the last one, negative b times b squared, which is negative b cubed. So what do we have left? We have 6 terms, 4 cancelled, 2 left. A squared minus b squared, right here. So again, the form is the way it is, not because I want to have it that nice, but because you can show it by multiplying, right? There are no beliefs in mathematics. This is science. You can justify it. And justification always underlines the beauty of logic. So there are always things that are really falling into place in a proper way. Beautiful. If you can remember this. So again, how do you remember that? The first parenthesis here 2 terms, the second parenthesis is 3 terms. The first parenthesis is the same as this one without cubes. The second parenthesis you have all products of 2. A times A in alphabetic order. A times A times B, B times B. That's it. A squared, AB, B squared. Just write them down. Odd ones are plus, plus, plus. The even ones could be negative, but it has to be opposite to what is here. So this is negative, this is positive. In this story here, this must be positive because this one is negative. Okay? Now, how do you use that? Alright, well, let's see. I'll give you an example. X cubed minus 8y cubed. Can you see cubes? You should be able to see cubes. Cube of x, cube of... Now if you don't see, maybe you should write them down. Cube of x, 2y cubed. 2 times 2 times 2 is 8. And there is difference. So you do have difference of cubes. So now how are you going to do this? 1, 2. 2 terms, 3 terms. You don't need to spend too much time thinking about it. So what do you write here? This stuff here without cubes. X minus 2y. Second parenthesis, x times x. Now you gotta remember, it's gonna be plus here. X times 2y. You multiply, a times b, right here. And the last one, which usually people lose concentration on the last one, right? You did everything right, but then somehow you relax and then you blow the last one. This square, you need to square it. If you don't know how to do that, make sure you use a scrap paper. So that goes on the last place. Okay? Usual mistake that people make is they put 2 and then they put y squared. And that's not good enough because you have a 2 times 2, which is 4. So if you do everything right here and then you put 2 here, it's going to be wrong. So you don't lose a concentration, make sure you do everything. Okay? Now in the paper I have a slightly different example, so let me do that. I'm going to do something else, completely different. Alright? So now you could ask question, do I have anything I can work with? Common factor? Absolutely not. X, 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 X. No X here. Done. Maybe factoring by grouping. Yeah, factoring by grouping is going to work, but you need to produce no less than 6 terms. That's how it would work. So that's just not gonna be something you want to do. So basically, you're left with thinking about it. Maybe you have some form. Of course, you have a sum of two cubes. How do you recognize cubes? Any power that is divisible by 3 is a cube. Why? Because when you multiply this, this is a power of power. 2 times 3 is 6. So 6 is divisible by 3, which means you divide, you get 2. 2 times 3 in the base is 6. In here, of course, you already know that 8 is a cube of 2. And this guy is a cube of a cube. Again, if you cube 2, you get 8. If you cube, you're going to multiply 3 times 3, which is 9. So you have a sum of 2 cubes. This, the very form on top I have. So now you're just simply going to write that down. 2, 3. You have to be careful. Without cubes. I mean, without this cube and this cube, right? You still have cubes in it. You can say, oh, maybe I can now continue this story. This is also sum of cubes. Yeah, but the 2 is a cube of cube root of 2. So we don't do that. But that will be fraction, decimal. Actually, not a decimal, something really worse. Okay, so we're going to leave it that way. Now, what's the second parenthesis? This squared. X squared squared. Use scrap paper. That's x with the power of 4. Okay? Then you're going to have to multiply this one and this one. So you get negative. Negative. 2. 2 is here. X squared y cubed. And now don't lose the concentration. You have one more to go. Square of this guy. Square of the second one. Square of this guy. 2y cubed times 2y cubed. Make sure you do the square. You got 4y with the power of 6. That goes at the end. Okay? Again, if you do everything right and you know what you're doing and you know that you are using this particular form, everything is gonna be great. But if you make a mistake in the last term because you just didn't bother to do this on the scrap paper and you were not careful, you were trying to do it in your head, then you're not gonna have it. You're gonna have something incorrect. Oh, I get a question that people from WebAssign are writing, how is this incorrect? Well, it's incorrect because you're careless. You didn't have the concentration to do the last one. Okay, this is what usually people make a mistake. They do everything right. They do this one okay, this one okay, this one okay, this one okay, and blow it the last one. All right. All right. So be careful. You need to have a squared, ab, b squared. The second one is minus here. You will always have a minus either here on the second one or here on the second one. So the question is what is here? It's plus here, so there's going to be plus here. The negative is going to be in the second parenthesis. Okay? And again, you can do this also with the fractions that you would never factor any other way. A cubed over 8 plus 27b with the power of 3 cube. Okay? You have a cubes? Yeah. Cube, cube of 2, cube of 3, cube. So you have a over 2 cube, and you have here 3b cubed. Okay? Cube of a, cube of 2, cube of 3, cube of b. Power rules. So how do you factor that out? Apparently, again, this piece here, sum of cubes, a half plus 3b. I gotta remember that, so I'm just simply adding these two guys. I mean, I'm just writing this without cube and cube. And the second one, I need to cube this. Oh, excuse me, square. I need to square this. So that's an a squared over 4. If you don't see that, do the scrap paper thing. And then you have negative. Negative is going to be this guy times this guy. So you have a times b times 3 times 1 half. That's 3 halves AB. And finally, the last one, Do not lose the concentration. You have to square this. That's 9b squared. Use a scrap paper to do that if you don't see it. Done. Okay. Now you could ask, is there any more forms? Yeah, there are more forms. I'm not going to bother you with that. So there are two more forms that will be with cubes. So that will be a cube of a sum and a cube of a difference form. But there are 4 terms polynomials. So I'm not going to bother you with that, because that will be factoring 4 terms polynomial. So I'm not going to bother you with that. I'm going to leave that for some other class. Okay? Next question you might ask, alright, all of this factorization is lots of stuff you need to learn. What do you use that for? I already said that you use that for the cancellation in fractions. When you need to cancel the common factors in the fractions, you need to have common factors. So which means you have to factorization in the numerator and denominator. Then you can cancel the common factor. Now if you don't have factorization, you won't have factors, you're not going to be able to cancel. So we're going to be talking a lot about it after the test number 3. But another thing you're going to use that is in equations. And in equations, it's going to show up very often that you're going to need to that. It's called a zero product property. Zero product property is this one. Right there you can immediately notice that in this zero product property you need to have a zero and you need to have product. So apparently because of this you will need to have factorization. I forgot to write property here. It's not zero product makes no sense, right? Property. Okay, what is zero product property? The zero product property is very easy to explain. If you multiply 2 numbers and you get the result to be 0, then you have A0 or B0 or A equal B equals 0. In other words, either A is 0 or B is 0 or both are 0. You cannot get 0 if you multiply 2 numbers that neither of them would be 0. That's zero product property. Right? This sounds very natural to you because you know when you multiply 4 times 5 you get 20, you don't get 0. You have never seen in your life that you multiply 2 numbers you will get 0 if one of them is not 0. So I think this sounds natural to you. But in mathematics we need to justify everything. So how do I justify this? Well, I can say, alright, now I have to conclude that either this or this is 0, or both. So if A is not 0, if A is not 0, then I can divide with A. You can divide the equation with non-zero number. So you divide the equation with A. You divide this with A, you get B. You divide this with A, is 0. Divide with anything is 0. Conclusion, B is 0. So if A is not 0, I can divide with A and then B is 0. Okay? That's a justification. I just did a little logic here. So if A times B is equal to 0, then either A is equal to 0 or B is equal to 0 or they're both 0. This is non-exclusive, right? Either they're both 0 or one of them is 0. It could be A or B. These are non-exclusive options, right? There are actually 2 options here. Well, 3, sorry. There are 3 options, yeah. They could both be 0. One of them, the A might be 3 and B might be 0, or the A might be 0 and B might be 5. That's the only way you can get this 0. Okay? So now you can say, this guy is making lots of story about something really simple. What do I need it for? You need it for equations. So let me show you. Somebody will ask you, solve this. Find the solution. Okay? Now, most of the people will be doing guessing. Maybe I can guess this. Try 1, try 2, try 3, try 4. Maybe you can find it. Okay? And if there are integers, if the solutions are integers, you will find it. Because it's really not that hard. I cook it this nicely so you can find it. But one of them is non-negative, so maybe you will never find it. Because people think, 1, 2, 3, 4, 5, 6, 7, 8, 9. Nobody's going to think about maybe -1, -2, -3 or something. Right? So this is what you're going to do. You are going to have 0. You're going to have product. And then you're going to use 0 product property. In that order. From left to right. Get a 0. One side must be 0. Subtract 12. Now you have a 0. Accomplished. Now you need to have a product. Now this is trinomial, and the whole story we had today and the last time is how to factor this thing. How to get a product. So you are now in the very beginning of the last time we had story last time, which would be the story about trial and error. Product is here, sum is here. What are we talking about? 4 and -3. So trial and error, this is it. So again, 4 times -3 is -12, 4 plus 3, plus 4, -3 is 1, right here. So the factorization is the key here. If you don't know how to factorize, you can do nothing here. You can start guessing again. So the factorization is in the game. So now you have product. The next step is use a 0 product property. What did we just say? You have a product of two numbers. First number, second number. And that is equal to 0. So you have two options. Option A. By the way, you can clearly see that this guy and this guy are not the same. Right? This is some number whom you added 4. And this is the same number whom you subtracted 3. That cannot be the same. If you add 4 to something and you subtract 3 from something, it will not be the same. So you have only two options. It's either this guy being 0 or this guy being 0. They can be both 0. Okay? So the option A is that x plus 4 is equal 0. If x plus 4 is equal to 0, x is -4. This is the one you would never guess. Or maybe you would, but I don't know. I have it now. Option B, or B is that this guy is equal to 0. If x minus 3 is equal to 0, then x is equal 3. Okay? So people say, oh, it's either this or this. Right? It's the first solution, second solution. Both of them are solutions. Because if you plug in -4 here, this will turn out to be true. You should check that, because in a test situation, when you find solutions, you should check them. There are two solutions here. Now, the x, of course, cannot be -4 and 3 at the same time. But each one of them is a solution. -4, you plug in here. Turns out to be true. 3, you plug in here. Turns out to be true. Well, that's an easy one to check. 3 squared is 9, plus 3 is 12. 12 is equal to 12. This one, you should check that. Okay? You can definitely do that. Let me give you another example. So again, this is where you use the factorization. Use the factorization to solve equation. This has been done for hundreds, if not thousands of years. Factorization to solve equations is something that we have been doing for at least 800, 900 years. The human civilization. Since we know about equations, so we know about equations for 2,000 years. Okay? We didn't write them like this. We write them today, but we know about equations for 2000 years or more. Okay? So, here you have a question. Solve this, meaning find when is this true. And now again, you know, people will, if they don't know to do anything better, they'll be guessing, you know, what can I find out? Maybe 1, maybe 2, maybe 3, you'll never find it. Because this guy is actually fraction. The solution is a fraction, you'll never find it. Nobody ever guesses fractions. Okay? So how are you going to solve it? Zero product property. The first goal is to get a 0. Subtract 10x. Now you have a 0. Turn this into a product. You can do that by guessing, or trial and error, right? But no, I actually have to recognize the form. This is the square of 5x, and this is the square of 1. And when you multiply 5x and 1, what do you get? 5x. And when you multiply that with 2, you get 10x. That's what you have in the middle. So this is the form that we did today. And we call this form square of difference form. In other words, you have 5x minus 1 squared. That's your product. 5x minus 1 times 5x minus 1. Again, square of this guy, right here. Square of this guy, right here. This guy times this guy times 2, right here. That's the form we had today. So I'm going to write it one more time. I hope you can see it. A minus b squared is equal to a squared minus 2ab plus b squared. That's the form I'm talking about. A squared, 2ab negative, b squared. That's the form we did today. Square of difference. Now if you don't know that, you're not going to be able to get a product. Okay, now, how can you have this equal 0? This is a product of two numbers that is equal 0. Now both numbers are the same, 5x minus 1. So you have only one option. This number is 0. When you multiply a number with itself and you get 0, the only way you can get 0 if that number is 0. Either the first one or the second one is 0. Both are the same, so the number must be 0. So what you have here, conclusion is that 5x minus 1 is equal 0, which means that 5x is equal 1, and that leads you to conclusion that x is equal 1/5. Okay. 5 times x is equal 1, so x is a fifth of 1. So you get the solution 1 only one solution. 1/5. You will never guess this. That 1/5 is the solution here. You try to plug it in 1/5 and you'll see. It's really not that hard to do that. You should always check. Whenever you have a test situation, you should always check your solution. So 1/5. This should be true, right? If you found the correct solution. This is square, so it's 25 times 1 over 25 plus 1 is equal 10 times 1/5, that would be 2. So you get 1 plus 1 is equal 2, and that of course is true. So you know you have a correct solution. Very important. Okay? So this, if you didn't have any better idea before, now you know that we will use factorization when we need to solve equations. And we need to solve equations by using zero product property, which is very often in the game. It works with 3 numbers too. You got a times b times c is equal 0. If this is the case, then a is equal 0, or B is equal 0, or C is equal 0, or any combination of two of them is equal 0. Or all three are equal 0. That's different options here. But it has to be one of them must be 0. You can't have them all three being different than 0 and have the product being 0. So this is a 0 property, works also on more than on 2. It works on 3 or 4 or 5 or whatever. Okay? You will use this. In a serious algebra, we use this also. So this is very important property. It's a sophisticated property. It's a property we use in a very serious algebra. Okay? A lot more than what we are studying today. So this is a property to remember. Okay? All of those forms, you need to remember that, but that cheap stuff. Zero properties are more serious business, and we do have that. That's important thing. Okay, let me do just one more general factoring just for fun. To finish that today, I'm going to do the factoring of something that looks quite complicated. You can see that sometimes with fractions. I'm trying to make up example that is slightly different than you have in the lecture itself, which is okay. Let's see. Well, that's good enough. Okay, some copying one from the lecture. Okay. So somebody's going to say, factor this thing here. And, right? You say, how do I factor this? Well, for one thing, you have a common factor. First of all, when you see denominators, you will always factor out the least square denominator. So if this here is, I don't know, 6, then it will be 12. The least square denominator. But right now the least square denominator here is just 4. So you factor out 4. That's one thing you're going to do. The next thing you're going to do is you can see the 3 in both of them. 3 times 125. I mean, this number is divisible by 3. I think if you have been studying algebra properly in the past, then you know when you sum these 3, you get 15, and if that is divisible by 3, 15 is divisible by 3, then the whole number is divisible by 3. But then you can try this with a calculator. This is divisible by 3, so you can take 3 out. Now I also like to take the negative out. Although it's only one place here. But then it's here too. This is negative, negative, positive. This is negative times negative. So I'll take that out too. Powers. You can see an x also. So this is your greatest common factor. So what is left? Out of the first one, I took it out, I took it out, I took one x out, I took minus out. So I have an x, and x, because I have 4 of them here. So I took one out, 3 are left. Out of the second one, I took one minus out, 1 is left, minus is plus. I took this guy out, and I have 3 taken out of this. 3 times 125, so I have 125 left. And I took the x out. So I might want to write this parenthesis a little closer here. Okay? What now? This is not a prime. This is a difference of 2 cubes. A cubed minus b cubed is equal to a minus b times a squared minus plus ab plus b squared. This is the form we studied today. So you have to recognize this form. Okay, you keep this guy. 3/4 x. This one, 2 parentheses. 2, 3. Just like that. This is a cube of 5. 5 times 5 times 5, 125. 125 is a cube. Oh, I didn't say that, right? Because that is such an obvious thing to me. Cube of 1 is 1. Cube of 2 is 8. Cube of 3 is 27. Cube of 4 is 64. Cube of 5 is 125. And then after that I don't know. But cube of 6, I'm lying. Cube of 6 is 216. Cube of 7, I don't know that one. I don't remember. So you gotta remember this couple of cubes. 125 is a cube of 5. Okay? Cube of 7 I think is 343, I believe. I don't know, I don't remember. Anyway, so 125 is a cube of 5. So now you just write this stuff without cubes. It's a story of this form. And then you write here the square of this guy. This time this, with plus, because plus is on the second place there, because it's opposite to this one. So you get 5x, or x times 5. And then you write the square of 5. Done. Here's your factorization. What cheap one? It doesn't look like easy one, but again, the common factor is out first. This is a common factor, and then you do the difference of two cubes of factorization. Okay. So this is something, I don't know, some people might not see that well. Okay. You will see sometimes stuff like that. Okay. In your homework, they will probably ask you, some places they will ask you to factorize something like this, maybe. Factor this. I'm trying to adjust this nicely. I'm just gonna keep one here. It's easier. Let's see. I got one. Let's do it like that. Okay. So what do we do this factorization, something like that? So I'm not having anything particularly special here. Well, it says factor this completely, so get the primes here. This is what we do. We factor out the greatest common denominator, which is 4 here. Excuse me, least common denominator, which is 4. On the top you have nothing to factor, it's just 1. You could have had something else. Then you have the powers, you have an x here. And now what is left? Let's see. So if you factor out 4 here, to have 4 here, you need to have a 2 on the top, right? Because that would be 1/2. So which means that you're gonna have 2 left here, and 1x is left. Out of the second one, I factor out 1/4, so I have an x. Uh-oh, I took x out, so I have 1 only. Okay? So you'll see that when you see that in the homework and you have some fractions that you need to factor, that's what you're gonna do. I'm not gonna bother you with that in the test, but that's sometimes you'll see in your homework. Let me give you another example with factoring fractions. So something like this. So factor this out. They want you to factor in the homework, they want you to factor the fractions. Because there's nothing else there. Maybe I could just put an y here, just for fun. Alright, so factor this, okay? This is what you do. you need to find the least common denominator, which is going to be 12. So then you're going to write with that denominator. So this is going to be 12, 4, right? You're building it up. Multiply with 4, multiply with 4. This is 1/3. Now factor. What do you have? On the top you have nothing in common, 4 and 3. Nope. On the bottom you have, I forgot to get 12 here too. I need to get 12 here, and I need to get 9 here, right? So this is 3/4. So now, on the top I have nothing in common. I have 2, 2, I have 3, 3 here, but on the bottom I have 12. That goes out. X squared, don't have an x's, nothing. Y, I do have y. Y out. So what is left? Just read. 12 is out, 4 stays. Y is out, x squared stays. 12 is out, well, minus stays. 12 is out, 9 stays. Y is out. That's it. You're not yet done. So why? Because this is a square and this is a square. So you have the difference of square formula. Difference of square is a minus b times a plus b. Okay? So I have 1/12 y square of 2x square of 3. Now I'm done. Okay? So let me repeat this one more time. Slowly. So, let's say you have a question. Factor this completely. Which means, give me the primes only. The first thing you're going to do, you're going to factor the fractions. You can't factor the fractions, we have nothing in common. On the top, you don't have a 3 here, you have only 3 here. That's the only prime. On the bottom, you have a 3 here, but you have a 2 and 2 here. So you can't do that either. Nothing in common. I mean, or you can say, well, I have a 3 here, I have a 3 here. Yeah, but they're on different places. This one is in denominator, this one is numerator. So you can't factor it. You can't factor the from one term something that is in numerator, from another term something that is denominator. That's not a common factor, because in one place it's a factor, another place is a divisor. That's a divisor, 1 divided by 3. This is a factor, 3 times 1/4. So you need to have it on the same place. So what you need to do is to get the least common denominator, which is going to be 12. 3 and 4, the least common denominator is 12. So that's adjustment. 12, you multiply with 4, you multiply with 4. Now this is 1/3. You keep the rest. Again, the same thing here. 12. You multiply this with 3, multiply this with 3. Everything else stays. Okay? Now you can factor. On the top, 4, 2 times 2, 3 times 3. There's nothing in common on the top. But you have a bottom, which is common. 12 and 12. So 12 can be factored. And then you go with the powers. X squared, no x's, nothing. Y, y. And then we have what is left. What do we have? 12 out, 4 stays. Y out, x squared stays. 12 out, 9 stays with minus. Y out. Okay? And you could say here, oh, I'm done. Well, you can still write this as a 3 times 2 times 2, right? It's just like proper factorization into primes. But you can just leave it. You're not done yet because this is not a prime. So you have to really use that property over there. So now you're going to have the end of the story. 2x minus 3, 2x plus 3. Okay? So I wasn't bothering you by factoring out fractions and things like that, but if you run that in the homework, pay attention to that. To be able to factor fractions, you need to have a common denominator, which means the both fractions that you don't have a common denominator. If you don't have a common denominator, if this is 4, that's peanuts. You have a common denominator. But if you don't have a common denominator, you need to have a common denominator. So you're going to build the fraction up. So this is 1/3, this is 1/3. It's just written differently, right? So multiply this with 4, and multiply this with 4, so now it's the same thing, and you have a 12. This one you also need to have a 12, and you multiply this one with 3, you multiply this one with 3, so that's how you have a common denominator. Now you can factor it out. The denominator can be factored out only if it's a common denominator. If it's not, then you don't. Until you get the same common denominator. Okay? So if you run into homework problems, stuff like that, into homework problem that contains the fractions with different denominator, remember this. Okay? Now, I'm done with this stuff. Everything I wanted to talk about factorization, I already said. So this is the very last lecture on the factorization and a lecture on special products. And I also talk about a little bit about equations here. So this is the stuff that is your last homework before the test number 3. And the next time we meet, we don't really meet, but the next time you have a class, it will be a test, which is on Monday. And it will include the lecture number 9, the lecture number 10, the lecture number 11, the lecture number 12, which is a long lecture on factoring, and the lecture number 13, which is the special products lecture. These 5. So you have those homeworks that you need to work on. I'm assuming you have already done some of that stuff, then you didn't leave all the homeworks for the last 2 days, I hope. But you need to work on those 5 homeworks, and once you complete those 5 homeworks, you're going to be ready for the test on Monday. Okay, so we have a test on Monday. There's nothing else going on Monday. You're going to get the test, and you will be prepared for the test if you do the homeworks. Okay, so you let me know if you have any problem. Over the weekend I'll respond to anybody's email and any questions about the test you might have. But the test is a typical test we had like last time. We're going to have a 2-hour test, and the stuff is going to be from the homeworks, and I'll select the problems and I'll put that there. I'll give you 2 tries on every problem. So you need to prepare yourself. You need to do the homeworks for that test. Okay? So I'm going to end up this story today, and the next time we meet, or the next time you log in, you're going to be doing the test. Okay? Good luck.